Hi everyone, myself B. Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today I want to discuss about the Fourier series form problems in the interval minus pi comma pi. Okay, already we discussed with the previous classes with the basic concept of the basic definitions and Fourier series in 0 comma 2 pi interval. Now we'll discuss with the Fourier series problems in minus pi comma pi. Okay. For that, first question, express f of x is equal to x minus pi as a Fourier series in the interval minus pi less than x less than pi. Okay. For that, what is the function? Here, f of x is equal to x minus pi in the closed interval, that is minus pi comma pi. Okay. In that interval, what about the formula? An by 2 plus sigma n is equal to 1 to infinity an cos nx plus bn sin nx. An cos nx plus bn sin nx. Then f of x is equal to, substitute there, that is x minus pi is equal to an by 2 plus sigma n is equal to 1 to infinity an cos nx plus bn sin nx. Okay, for that here we have to find their a naught value, an value and bn value. Okay, in that, what about a naught formula? A naught formula 1 by pi into integral minus pi to pi f of x dx. Integral minus pi to pi f of x dx. That is 1 by pi into integral minus pi to pi. In place of x, I am substituting the given function x minus pi into dx. Okay, then different for that. Okay, here the function is x. Okay, then the integration with respect to what? Minus pi comma pi x dx minus pi into integral minus pi to pi. Here 1 into pi into dx means here pi I'll take outside, that is pi. Okay, from that 1 by pi into here x is, generally we know that within the interval minus pi comma pi, x is a odd function. X is a odd function. If the limits minus a to a f of x dx, if f of x is odd, then for that case, then directly that the value is equal to how much? 0. Then the value is equal to 0. That is 1 by pi into, then directly this is equal to 0 within the limits minus pi comma pi. Generally you have to consider that as minus a to a f of x dx. If the function is odd, directly that is 0. If function is even, for that case, what is the formula? 2 into integral 0 to a f of x dx. Okay, then this is 0 minus, okay, 1 observe here 1. For that, I'll take minus 2 pi into 0 to pi. Here 1 integration as x, that is minus 2 pi into x limits 0 to pi. Okay, minus limits 0 to pi. For that, substitute, that is 1 by pi into here pi cancel, that is minus 2 into pi minus 0. This is equal to, okay, there pi cancel, that is minus 2 pi. This is a naught value, that is a naught. This is a naught, therefore a naught is equal to minus 2 pi. Okay, this is the first question, a naught value, that is minus 2 pi. Next, for finding here, now we have to find an and bn values with respect to the interval minus pi comma pi. Okay, for that I'll take, what about the formula for the an? That is 1 by pi into integral minus pi to pi f of x into cos nx dx. F of x is equal to what? The given question, that is x minus pi, that is 1 by pi into integral minus pi to pi x minus pi into cos nx dx. Okay, after multiplying within the brackets with cos nx, that is 1 by x into integral minus pi to pi x into cos nx dx minus pi into integral minus pi to pi cos nx dx, cos nx dx. Here once observe, generally cos nx within the interval minus pi to pi is an even function. There x is an even, cos nx is an even function, then x into cos nx. If cos nx is multiplied with x, for that case it is an odd function. This is an odd function. Therefore, here directly within the interval minus pi to pi, x into cos nx is 0. X into cos nx is 0. If you forgot this formula, for that case we have to take the formula of integral uv. Integral of x into cos nx, u into v formula, minus, or else directly, if you know this formula directly, this is equal to 0. And integral minus pi to pi cos nx dx. Okay, now integrate cos nx with respect to x. That is cos nx integration is, that is minus 2 into cos nx is even term, right? Even term. For that case, okay, integral minus a to a f of x dx is equal to, if f of x is even function, for that case, how we are writing that formula? 2 into integral 0 to a f of x dx. Same concept I am applying there. For that, here 2 into integral 0 to pi cos nx dx. That is minus 2 into, okay, cos nx integration is sin nx by n, limit points 0 to pi. Substitute first upper limit, that is minus 2 by n into sin n pi minus sin 0. That is minus 2 by n into sin n pi value. Directly we know that sin n pi value 0 and sin 0 value 0. If you want to, if you are taking the limits within the sin 0 to pi means, then directly sin is always 0. Okay, then here sin n pi is 0 and sin 0 0. Therefore, an value directly is equal to how much? 0. An is equal to 0. And next, for finding Bn, that is 1 by pi into integral minus pi to pi f of x into sin nx dx. That is 1 by pi into integral minus pi to pi. What is the function? X minus pi into sin nx dx. That is 1 by pi into integral minus pi to pi x into sin x minus pi into integral minus pi to pi sin nx dx. That is 1 by pi into 2 into integral 0 to pi. Again I am taking here, I am applying the same concept of the even and odd function. Here x into sin nx is an even function. Generally x is odd and sin nx is even, but if the two are multiplied, that is definitely it is an even function. Okay, for that case I am taking the limits 2 into integral 0 to pi x into sin nx dx minus, here directly sin nx is odd function. Therefore, within the limits minus pi to pi, that is equal to 0. That is 2 by pi into, okay, this is completely 0. From that I'll take 2 outside. That is 2 by pi into x I'll take outside. Sin nx integration is minus cos nx by n minus 1 into, that means here I am applying uv formula. Okay, I am applying uv formula for x into sin nx. What is the formula for the uv formula? X into sin nx integration is minus cos nx by n minus x differentiation 1 and cos nx by n integration. Already there minus into sin nx by n square. Okay, this formula continue up to the constant derivative of the function x. There x derivative next 1, so that we have to stop the formula of the uv. Okay, then here, then substitute the limit points of 0 to pi, that is 2 by pi into, okay, minus, substitute the limit points, that is minus pi into cos n pi by n plus 0 minus, okay, here substitute all, already I discussed, if the sign terms are there within the limits 0 to pi, then directly that is sin n pi value 0 and sin 0 value 0. Then 2 by pi into minus pi cos n pi by n. That we know that cos n pi value minus 1 whole power n. Similarly, what about sin n pi value? Sin n pi value 1. that is minus 2 by pi into cos n pi. There substitute cos n pi value is minus 1 whole power n. Okay, once observe here minus, I'll take inside the brackets of that, that is 2 in by n into minus 1 into minus 1 whole power n. Here bases are equal, then we should add the powers. Then for that minus 1 whole power n plus 1. Okay, this is also right answer, or else if you want to reduce that, 2 by n into minus 1 whole power n plus 1. That is also correct answer for finding Bn. Now from that series, now we know that A naught value, An value and Bn value. Okay, now substitute A naught, An, Bn values in the first equation. What is that first equation there? First equation, f of x is equal to x minus their function f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity an cos nx plus sigma n is equal to 1 to infinity bn sin nx. There we have to substitute the a naught an values. Okay, a naught an values. Okay, this is the formula. Now substitute it in the first equation. That is, there I have to substitute. What about A naught value from that? A naught value minus 2 pi. Minus 2 pi. I am substituting there. That is minus 2 pi plus sigma n is equal to 1 to infinity. If A n value is A naught is minus 2 pi. A n is equal to 0. B n is equal to 2 by n into minus 1 whole power n plus 1. Okay, from that substitute there. After substituting here 2 cancel directly, we get minus pi and an is 0. An is 0 and what about bn? 2 by n into minus 1 whole power n plus 1 into sin nx. 2 by n, this is 2 by n. Okay, now after substituting that, now expand the sigma value. Here sigma starts from n is equal to 1. That is minus pi plus, here I'll take 2 outside and now I'm starting with n value is equal to 1. That is minus 1 whole power 1 plus 1 into sin nx. That is minus 1 whole square means that is 1. That is sin x minus minus 1 whole power 2 plus 1. That is minus 1 by 2 into sin 2x. If you are taken n as 3 minus 1 power 4. That is 1 by 3 into sin 3x minus 1 by n value is 4. That is 1 by 4 into sin 4x. This is the required answer for the function x minus pi within the interval minus pi comma pi. Okay, this is the concept for finding the limit points for minus pi comma pi. Okay, next question. Find the Fourier series to represent the function e power minus ax from x is equal to minus pi to pi. X is equal to minus pi to pi. From that, deduce from this that pi by sin h pi is equal to 2 into 1 by 2 square plus 1 minus 1 by 3 square plus 1 plus 1 by 4 square plus 1. Okay, for that, first here two parts are there in the question. First, we have to find the Fourier series for the function with e power minus ax. After that, from the series, we have to deduce the following. What about that following this? Okay, for that, first find out the Fourier series. Then the function e power minus ax be represented by the Fourier series a naught by 2 plus sigma n is equal to 1 to infinity an cos nx plus bn sin nx. That is equal to e power minus ax. Then what about a naught value there? A naught formula 1 by pi into integral minus pi to pi e power minus ax into dx. That is 1 by pi into, what about the integration of e power minus ax? E power minus ax by minus a. Then the limits minus pi to pi and after that substitute minus 1 by a pi into e power minus ax minus e power minus a pi. Okay, in place of x I'm substituting upper limit and the lower limit point. That is e power a pi minus e power minus a pi by a pi. There a naught is equal to, there is no 2 and then a here e power minus ax by e power minus a pi by 2. There 2. Okay. Then I'm sorry. This is A only correct. Okay. And that not 2 there. And e power minus a pi minus e power minus a pi into 1 by a pi. This is exactly is equal to what? Sin h a pi by a pi. Sin h a pi by a pi. This is a naught. Next, an value. 1 by pi into integral minus pi to pi, okay, e power minus ax into cos nx dx. Here the function is e power minus ax. Once observe, for finding an after substituting the function within the limits minus pi to pi, there is direct formula for this, that is e power ax into cos bx dx is equal to e power ax by a square plus b square into a cos bx plus b sin bx. A cos bx plus b sin bx. Okay, just you have to apply this formula from the above one, that is e power minus ax by here a square plus b square. B square means n square. A square means 1 a square into a cos bx plus b sin bx. A means minus a into cos bx plus b into sin bx. From that, an is equal to 1 by pi into e power minus ax by a square plus n square into minus a cos n pi plus 0 minus e power pi a pi into a square plus n square into minus a cos n pi. After substituting the limits, there's okay. This is after substituting the limits. Okay. From that, what is common term? Here, what is common? There, I'll take a cos n pi by a plus n a square plus n square is common, and the remaining e power a pi minus e power minus a pi, that is equal to 2a into, okay, this is equal to exactly is equal to what? 2a into cos n pi into sin h a pi by pi into a square plus n square. This is the value for that here. And here, what about cos n pi value? Cos n pi value minus 1 whole power n into 2a into sin h a pi by pi into a square plus n square. Okay. Then for that, this is the required value for finding an. Next, bn, that is 1 by pi into integral minus pi to pi e power minus ax into sin nx dx. That is again which is in the form of direct formula for that, integral e power ax into sin bx. For that, whatever the formula, e power ax by a square plus b square into a sin bx minus b cos bx, that is 1 by pi into e power minus ax by a square plus n square into minus a sin nx minus n cos nx. Okay, here b value is n and a is a within the limits minus pi to pi. That is 1 by pi into integral e power minus a pi by a square plus n square into minus n cos n pi minus e power a pi in pi a square plus n square into minus n cos n pi. For that here I'm taking whatever the common terms from that, n into cos n pi is common, and e power a pi minus e power minus a pi by pi into a square plus n square, that is minus 1 whole power n into 2n sin h a pi by pi into a square plus n square. Okay, this is the value of the bn. Okay, now substituting the values of a naught, an and bn values in the first equation. From that, e power minus ax is equal to, what about a naught sin h ax by a pi into there 2. Okay, there 2. In that, there 2. Okay, 2, there 2. That is 2 sin HAX there. After substituting there 2, then 2 cancel, that sin HA pi by pi plus sigma n is equal to 1 to infinity minus 1 whole power n into 2a sin HAX by pi into a square plus n square. This is the an value and this is bn value. An into cos nx and bn into sin nx. That is here, what is common term from the 3? That is 2 sine HAX by pi into 1 by 2a, a cos x by 1 square plus a square plus a cos 2x. If n starts from what? There, 1. That is a cos x by 1 square plus a square plus a cos 2x by 2 square plus a square plus a cos 3x by 3 square plus a square. Okay. Plus minus, here n value starts from 1. Minus 1 power 1 means minus 1 sin x by 1 square plus a square minus 2 into sin 2x by 2 square plus a square, for n is 2 and n is 3 means 3 sin 3x by 3 square plus a square. This is Bn. Okay. This is Bn. Therefore, this is the final answer for the interval minus pi comma pi, within the interval minus pi comma pi, e power ax Fourier series value. Okay. Once observe, this is the general procedure for finding a naught, an, bn values in the, okay, in the within the interval minus pi comma pi. But here one more concept is there in that, if the interval minus pi comma pi, for that case first we have to verify the function is even or odd. Okay, if the function is not an even and not an odd number, odd function, for that case we have to follow the same concept for finding the Fourier series for a naught, for finding a naught, an and bn values. If within the interval minus pi comma pi, for the given function is either even or odd, for that case that is the different formula. Then we have to discuss some concept with the next in the next class. Okay, thank you so much, thank you.
Like, share, and subscribe. Hit the bell icon for more updates.